Hey there, hi there, ho there. Hello. Just trying out some accent. Hello. What if I did the entire presentation in an accent? I know that'd probably annoy you just as much as it annoyed me. Anyway, welcome to Unit 9. We're now in the Paleozoic. All right. So we're coming out of the Proterozoic. Now we're in the Phanerozoic eon, which is broken up into three eras, and we're looking at the Paleozoic era. And we're just going to focus on the kind of the Earth history, the geology in this unit. Next unit, we'll focus on the life because there's a lot to go over. So let's jump into it. So here we are in the Paleozoic era, which extended from about 541 million years ago to 252 million years ago. And the Paleozoic era is broken up into a number of periods: Cambrian, Ordovician, Silurian, Devonian. Depending on where you're at in this world, if you're in the United States, you call it the Mississippian and Pennsylvanian. If you're in Europe, you probably call this period of time the Carboniferous. And then ending with the Permian. As we go through today, you probably won't hear me refer too much, or it's not broken, I should say this, it's not broken up by periods. This is going to be more so when we get into discussing kind of the living organisms of the Paleozoic era next unit. We're going to kind of break this up and define the Paleozoic era geologically by some events, by other geologic events. So just something to be aware of. So we're out of the Precambrian. We're now in the Phanerozoic eon, and we're going to focus on this little chunk of time, the Paleozoic era, which is just a paltry 6.4% of Earth's history, but a fascinating one nonetheless. So again, about almost 300 million years to take care of this unit. So some highlights of the Paleozoic. There was some major mountain building activity along the edges of the continent, along the continental margins. There was also a series of transgressions and regressions over the continental interior. When that happens, those are called eperic seas, if you hear that term coming up again, but that's just oceans that have covered, transgressed and regressed over the continent in past history. And all these were caused by fluctuations in sea level change, plate tectonic activity, glaciation, etc. Again, we'll focus on the geologic history of North America in terms of either the transgressions and regressions, these events, as well as, I should say, also mountain building events as well. We'll kind of throw in there rather than a period by period chronology. Oh, this is what happened in the Cambrian. Oh, this is what happened in the Silurian, so on and so forth. So we'll kind of maybe focus just on the major transgressions and regression events, of which during this time there were 4 of them. But we'll also sprinkle in some of those mountain building events as well. So let's talk a little bit of a review. Cratons. As Pannotia is breaking up towards the end of the Proterozoic, towards the end of the Proterozoic, Pannotia began to break up. But once the Paleozoic era started, so Pannotia broke up kind of before the beginning of the Paleozoic era by a few million years or so, about 100 million years. Right, which doesn't seem like a lot, but it is. But anyway, once the Paleozoic era started, there was kind of 6 major continents that were present. Each continent can be divided up into 2 parts, the craton and 1 or more mobile belts. So we'll get into that. So remember, craton is made up of 2 pieces, kind of the shield and the platform. The shield is really the remnants of pre-Cambrian, what we studied earlier, the Hadean, the Archean, and the Proterozoic. Those original rocks that were kind of put in place that by this time, as we're getting at the Paleozoic era, nothing is really happening to them. And the shield is the exposed original kind of crustal material of a continent. So again, shields were extremely stable by this point in the Phanerozoic eon and the start of the Paleozoic era. Again, extending out from the shields are the platforms. Those are the areas that are kind of covered with sediment. But at this time now, during the Paleozoic era, we're going to talk about these transgressions and regressive events. A lot of this is where a heavy amount of the craton is going to be buried under a number of sediment sequences. So the Phanerozoic sediment, which would later become sedimentary rocks, really takes place and buries that platform. Again, these sediments were deposited in widespread, relatively shallow seas that transgressed and regressed over the North American craton, Laurentia, if you will. So, right before Pannotia forms, this is kind of where we left it off as far as what the craton looks like. And then as Pannotia began to break up, parts of the craton were kind of pulled away with it. So this is kind of what we're left with coming into the Paleozoic era. So this is kind of what we're left with. All right, we still have, this is the craton. Part of it's going to remain exposed as the shield. Part of it's going to be buried as the platform. So to this, the North American craton, again, we're going to cover it in sediment. So there's going to be these transgressive and regressive events. There's going to be 4 of them. But we're also going to start to add kind of mountains towards the margins of these things, known as mobile belts. So these are elongated areas of mountain building activity, again, usually along the margins of continents, usually right along the edges of them. So during tectonic activity, when crustal deformation is occurring, depending on what's there. Typically now, as we're in this Phanerozoic eon, as the craton is weathering, there's a lot of sediment being dumped out, turned to sedimentary rock. So we have a lot of sedimentary rock being built along the margins of these cratons, and as these things are getting crumpled up due to tectonic activity, different continents crashing together, it's also going to be intruded by magma. It's also going to be creating metamorphic rocks with heat and pressure. So during this time in the Paleozoic, there's 4 mobile belts formed around the North American craton. Franklin, Cordilleran, the Ouachita, and the Appalachian mobile belts. Okay. Again, all of these tend to be kind of, for the most part, at least initially, folded up sedimentary rock that originally was sediment deposited in the shallows of the ocean along the continental shelf and continental slope. Just a little reminder, this is kind of a cross-section. If we're looking at the edge of a continent, for instance, the North American craton or Laurentia, the continental shelf is this kind of little shallow area that extends out for 10, 20, 50 miles from the shore itself. So you get some sediment deposition before we get the continental slope dipping down into the continental rise before it gets into this flat kind of ocean basin, the abyssal plain. But this is also where we're kind of meeting the oceanic crust, where the continental crust is meeting the oceanic crust. So, what North America, Laurentia, kind of looks like towards the end of the Paleozoic. So this is kind of the end of everything. We're going to explain a number of things here. So we have the craton, all right, which is made up of the Canadian Shield, all right. By the end of the Paleozoic, which we're going to go through this unit, here's the platform. It's this lighter gray stuff. This is all the stuff covered by sediment, all right. And then we add on these kind of mobile belts, these crumpled up mountainous regions that we add to the kind of edges, the margins of this of our continent. And so this is what towards the end of the Paleozoic era we're going to look like. So we're going to go through today and talk about the transgressive and regressive events that covered the platform, and we'll talk about the Appalachian and the Cordilleran mobile belt a little bit. We won't really get into the Franklin or the Ouachita mobile belt. I'm trying to do, just focus on stuff that's you maybe have heard of, for instance, like the Appalachian Mountains, or that maybe have had some impact on where we are. here in Arizona, at least in the west. So we'll talk a little bit about the Cordilleran, but the other two we won't talk on. And again, when we're focused on the geology of all this stuff, I'm going to try to relate as much as I can to North America. I mean, things are going on all over the world, right? What would eventually become all these different continents and countries. I mean, geology is happening everywhere. Plate tectonics is happening everywhere. But we'll just focus on North America because there's just a little too much to do the whole world. Okay? So we'll pause here. When we come back, we'll talk about paleogeography. See you back here in just a second.